spacecraft with a proper length of 200 meters is passing by an observer on Earth. It's traveling across a point, and it's going to try to move 200 meters across that point there. Now, the observer is going to see that happening at 0.79 microseconds. And we're going to try to find the velocity of the spacecraft. Now, let's remember that if we have this proper length of 200, this observer is actually going to see a smaller length, this contracted length, right? So we essentially have this formula that the L that was observed is going to be equal to the L of this plane, right? This proper time, the proper, divided by that factor. So we can just go ahead and say LP times the square root of 1 minus the V of this plane, square that divided by the C squared. So what we've done here is we've shrunk the length of the plane to what the observer would have seen. So now we can use the formula x equals vt, right? Because essentially you move this distance x, but remember, we thought it was 200, but the observer saw a smaller distance, so it wasn't really 200. It was actually more this distance here. So LP is 200, but we'll put that there. So 200 times the square root of this 1 minus the V of the plane squared over C squared. Then we could set that equal to V. Of course, it's still V of the plane here. And then there's the time observed here. So the time observed. So we can kind of make that equation there. From here, we're going to go ahead and move the 200 to the other side and square both sides. So we'll get something like 1 minus the V of the plane squared over C squared equals the V of the plane. And then we're going to have to square this stuff, so we'll put the V plane squared, and then we'll put this number 0.79 microseconds over this 200, but this is all going to be squared here. At this point, I'm going to try to move these V planes on this side, so there'll be some V plane squared. There's a 1 on this side, and then there's going to be some numbers that we're going to need to divide over on this side. And then we'll get a V plane over there. But I'm going to do that on the calculator. I'll start with the 0.79 microseconds here. And we'll have the 200 meters on the bottom. We'll square that. And I'll add this V plane C squared thing on the other side. So it'll be 1 divided by 3e to the 8. So we're just taking out the V plane squareds. So we'll get a number here. And this is what I can divide that 1 by. Alright, so now I could square root this. And that's going to be the velocity of the plane, but usually you have to divide this by 3e to the 8, so that way we get this fraction. So it'd be something like the V plane is 0.645 times c.